The next technique that we're gonna study is gonna call the trigonometric substitution. The trigonometric substitution will be used when you see the integral with the expression a square minus u square, a square plus u square, or u square minus a square. So it's gonna be three kind of this one. For example, you see that this one, you see 1 minus x square and 1 minus x square turned out to be, so you see 1 minus x square. So this guy will be a square minus u square. A is a constant, u is a function in x. Okay, so you can see that this one you have a equal to 1, u equal to x. So this is, we're gonna indicate them in this way. Another example is 1 over x squared and x squared minus 1. The thing that you see here is gonna be the yellow one. So you have x squared minus 1. So the thing that you see x squared minus 1. This one is u squared minus a squared. So this one, u is a function in x, like I said, and you have a is constant. So in this case, you're gonna have u equal to x and a equal to 1. Okay. And for number 3, you see the term 4 plus x squared. So for 4 plus x squared, it's gonna turn out to be u squared plus a squared, or a squared plus u squared. So you see 4 plus x squared, this guy will be a squared plus u squared. So you have a equal to 2 and u equal to x. Okay, so you have a equal to 2 and u equal to x. So this is how we see the equation. Okay, so when you see this expression, you're gonna be able to integrate this one. I use the different color, so let me just change this one to the green one. Sorry, I like to have is this the same corresponding to the blue one, the green one, or the yellow one, but it's not necessarily. The first thing that you see is going to be, we're going to simplify this integral by using the trigonometric substitution. So for the first term, you have a square minus u square. So when you have a square minus u square, you're going to substitute u equal to a equal to sine theta. So if you recall, this one come from the formula of dip arcsine. So you integrate. So you integrate 1 over square root 1 minus x squared dx. So this one is going to be arcsine x. And you integrate 1 over 1 plus x squared dx. So this guy will be arctan x. Okay, let me write this one a little bit smaller. So you have integrate 1 over square root 1 minus x squared dx. So this guy will be arcsine x. And you integrate 1 over 1 plus x squared dx. So it's going to be arctan x. And finally, you integrate x square root x squared minus 1. So this one, you have arcsec x. Okay, so they come from the thing that you see that you are having the blue case here, you are having the yellow case here, and you are having the green case here. So you're gonna substitute by the thing that you have for arcsine, arcot, or not arcine, arcot, arcsine, arctan, or arcsecant. So for a square plus u square, okay, for a square plus u square, you're gonna substitute u equal to a tan theta. And finally, for a for u square minus a square, you're gonna substitute u equal to a sec theta. Okay, and you're gonna compute du and you're gonna use the identity accordingly. So I'm gonna teach you next one. However, the thing that I like you to memorize also will turn out to be these two identity. So you're gonna have to know that sine square plus cos square equal to 1, and 1 plus 10 square is sec square, and sec square minus 1 is 10. So it's gonna be important also. Okay, so this will be the thing that we're gonna use for the techniques called the trigonometric substitution. Let's try to integrate this guy. So you see that you have a equal to 1, u equal to x, and you have 1 a square minus u square. So this guy, you're gonna use sine theta. Okay, so I'm gonna say that we're gonna use sine theta. So we're gonna let u equal to a sine theta. So you're gonna get x equal to sine theta for this substitution. The idea is very simple, basically. So it's going to be x equal to sine theta, and you're going to compute dx for me. Dx, you're going to dip sine, you're going to get cos theta d theta. Okay. And then what? And then you're going to integrate. Okay. So you have x cubed. X cubed will be just this x equal to sine theta. Okay, so let me highlight this term. So you have how many x? So you have one x here and another x here. Okay, so you're gonna plug in x equal to sine theta. So it's gonna be sine theta to the third over square root 1 minus sine theta square. So they are the orange one. So this is the term that you are having here. And you have dx. You have dx equal to cos theta d theta. Okay, so you have cos theta d theta. So this one is the yellow one. So in this case, you would get this one is cos theta d theta, and you're gonna integrate. So it's gonna be sine theta to the third cos theta d theta. Okay, and you see the thing that you have here is square root 1 minus sine square, and 1 minus sine square equal to cos square. Okay, and this guy turned out to be cos theta. So the bottom one turned out to be square root cos square, so it's gonna turn out to be cos theta for the bottom. Okay. The important part here is gonna be the mistake that you make is you use dx equal to d theta, which is incorrect. Dx will be cos theta d theta. Okay, so dx will be cos theta d theta. Be careful on this one. And you see that cos and cos will cancel each other. So you end up with integral of sine to the third. So you get integral of sine theta to the third d theta. And this one, you have to use 7.2 to integrate. Okay, so we're gonna use section 7.2 to integrate. Like I mentioned earlier that when you use the trigonometric substitution, you're gonna end up with the trigonometric integral that we studied in the previous section. Okay, so they are like support each other. So you have integral of sine cube, and this one is odd power of sine. Okay, so it's odd power of sine. So in this case, you're gonna write sine theta square sine theta d theta. So you split this one in terms of sine and multiply with the rest of the power of sine that you have, and then you're gonna let u to be cos theta, kind of opposite like I told you. So I get the u, I cannot use u, I gonna let w, okay, so I already use u. So I let w to be cos theta, so you have dw equal to, if cos is negative sine theta, d theta, okay. So you get here is gonna turn out to be negative dw, okay, so that's sine theta d theta, and you see that sine square turned out to be 1 minus cos square, okay, so that's my sine square. So you have what? You have this integral, okay, so it's going to be integral, and you have w equal to cos theta. So w equal to cos theta, so this guy will be w square, okay. So you get the green guy turn out to be 1 minus w square, and you have negative dw, and so you get negative, and you're gonna just integrate 1. You integrate 1, you get what? You integrate 1, you get w, and integrate w square, you get w cubed over 3, okay. And this one will be negative, and w equal to cos theta, so you get w and w here, okay, so it's going to be negative of cos theta plus cos theta to the third power over 3, okay. So this is how we have this trigonometric substitution. So you get negative cos theta plus square root this one, and you're gonna have to plus c for me for final answer. However, you see that we not have the final answer yet because we are beginning with x, okay. So I'm gonna mention here that we must answer in terms of x. Okay, so we must answer in terms of x. So can we find cos theta in terms of x? So the way to find cos theta in terms of x, you look at sine theta. You have x equal to sine theta, so you have sine theta must be x over 1, and this guy is opposite over hypotenuse. Okay, so you have opposite over hypotenuse equal to 1, and you will draw a right triangle. So you draw a right triangle, so you have theta, and you have x over 1 to be your hypotenuse and opposite. So you'll be able to solve the other side. So this guy by Pythagorean theorem, so you get square root 1 minus x squared, and you're gonna be able to conclude cos theta. Cos theta will be adjacent over hypotenuse of the angle theta. So you get square root 1 minus x squared over 1. Okay, so you get square root 1 minus x squared over 1. And this will be used to change cos theta. So you would get cos theta here equal to square root 1 minus x squared, and your final answer, okay, your final answer in this case turned out to be, I try to squeeze it here, so it's going to be 1 minus x squared, which is the cos theta, and you have square root 1 minus x squared to the third over 3, okay, and you're going to have to plus c for me for final answer. So this one is how we have the final answer in terms of x. Okay, so you see that everything turned out to be, you begin with something in terms of x, that you use the technique called the trig sub. You use u equal to x, and you have a equal to 1, and you substitute by using sine theta. Okay, so that's the thing. So basically, what is the line that you need to memorize? It's gonna be just the thing that you need to memorize turn out to be you see what and use what. Okay, so see 1 minus x squared, use psi. Okay, so you use psi. This is the thing that you need to memorize. So basically, it's gonna be just the first two columns. Okay, so it's going to be just the first two columns together with the trigonometric identity. Okay, the second one, you have integral of 1 over x squared, so square root x squared minus 1. And I mentioned before that you see x squared minus 1, so you see u squared minus a squared. You have a equal to 1, u equal to x. So you substitute. So you're gonna let u equal to a sec theta d theta. So u equal to a sec theta. So in this case, you're gonna have x equal to sec theta, and you would get dx equal to dipsec is sec theta tan theta. Be careful, it's not sec x tan x. Sometimes you just use the variable x and you have the wrong solution here. So you have the x equal to sec tan, okay, and this is my dx, okay, and you see that you need to substitute x squared minus 1. Let's compute x squared minus 1 a little bit here. So you have x squared minus 1 equal to sec squared minus 1, and sec squared minus 1 is 10 squared. Okay, so this one will be your yellow guy. So we're gonna substitute everything into the integral. So you're gonna get 1 and you're gonna get x squared. So you would get sec squared theta, and it's gonna be square root x squared minus 1. So it's gonna be 10 squared. Okay, and for dx, okay, like I mentioned before, for dx, it's gonna be sec 10. So it's going to be tan sec theta, tan theta, d theta. So this is your dx. Okay, so be careful on this one. It's not that simple. Okay, it's not d theta. If you have d theta, it will be incorrect automatically. And you see that this guy is nice. So you have sec tan on top, together with something also almost nice on the bottom. So you get sec theta on the bottom square. Okay, and you have square root 10, and square root 10 in this world is turned out to be just 10 theta. And you see that this guy 10 and 10 cancel each other, and you have sec square and sec. So you're gonna end up with just integrate 1 over sec theta d theta, and 1 over sec turned out to be cos theta integrate. Okay, and integrate cos theta, you get sine theta plus c. Okay, so this is how we have this formula, and this is how we have this integral. Okay, however, this one is theta, so we must find sine theta in terms of x. So you must find sine theta in terms of x for me. So you're gonna see that you have x equal to sec theta. From x equal to sec theta, okay, so you have x equal to sec theta, so it's gonna be x over 1, and so you get cos theta equal to 1 over x, and cos is adjacent over hypotenuse. So you draw a right triangle. So for this one, you get theta, and you have hypotenuse is x, you have adjacent is a, and you have by Pythagorean theorem, this side is going to be x squared. Okay, so not a, sorry, it's going to be 1. So it's going to be x squared minus 1. Okay, so that my adjacent, not adjacent, my opposite. Okay, so you get sine theta from this picture turn out to be opposite square root x squared minus 1 over x. Okay, so that will be my final answer. So it's going to be square root x squared minus 1 over x plus c for final answer. So you see the red thing that I wrote down here, you see that it's going to be finding sine theta in terms of x that you may need to find at the end. So you see that the trig sub is just this line. So this line is called trig sub. Okay, so the trig sub is here. So you guess the technique is called trig sub because you have the trigonometric substitution at the first line, and here it's going to be trig integral. And trig integral is 7.2. Okay, so that's the trig integral that you have. And the basic trigonometry that you use is at the end. You have to know the basic trigonometry here. So this one turned out to be difficult because some of you are weak on trigonometry and it's going to be involving a lot of algebra. Okay. However, practice makes perfect. So you need to practice this one kind of a lot. Okay, so the next one, you're gonna integrate x equal to negative 2 to x equal to 2 root 3, okay, 1 over square root 4 plus x squared dx. The thing that you see it is, you see 4 plus x squared, okay, and you here, you're gonna use tan theta, okay, so you're gonna let u equal to a tan theta. Okay, so you're gonna have x equal to 2 tan theta, and you get dx equal to dip tan, you get secant square theta d theta. Okay, so this is your dx, so it's going to be 2 sec square theta d theta. And you see that you also need 4 plus x square for the green guy. So you're going to compute 4 plus 2 tan theta square. So it's going to be 4 plus 4 tan square theta. Okay. So this guy will be what? Will be 4 outside, and it's going to be 1 plus tan square theta. And the thing that you have for the green one, okay, so for the green one will be just 4 times 1 plus tan square. And this guy will be 4, and 1 plus tan square by trig identity, so you get secant square. Okay, so 1 plus tan square equal to secant square. So this is how we get the green one. Okay, and you also see that I'm going to use another color. You also see that I have x equal to negative 2 and x equal to 2/3. Okay, sorry, not 2/3, 2 square root 3. So you're gonna have x equal to negative 2, okay? X equal to negative 2, so you're gonna have to change everything in terms of theta. X equal to negative 2, okay? So x equal to negative 2, so you get negative 2 equal to 2 tan theta. So you would get tan theta equal to negative 1. Okay, this allow you to get theta equal to arctan of -1, and arctan of -1, if you recall, is going to turn out to be -pi/4. Okay, so this guy will be -pi/4. Okay, so that for x equal to -2, let me move everything up a little bit. I just need one line more. Okay, that look nice. So for another guy, so you need x equal to -2√3. So you get -2√3 equal to x equal to -2√3. So you have -2√3 equal to 2 tan theta. You solve for theta, so you would get tan theta equal to -√3. And you solve for theta, again it arctan -√3, and it's turned out to be -pi/3 or 60 degrees. Okay. However, for using trigonometry, we're gonna use in terms of radian because you use real number scale. Okay. So for this one, you get I don't have negative sign. Sorry, I don't have negative sign. So I'm gonna erase this guy. I'm gonna erase this guy. And I'm gonna erase this guy. So it's gonna be just pi/3. Sorry. Okay. And then you're gonna plug in, or you're gonna do the trig sum. Let me do the trig sum. So here I'm gonna do the trig sum. Okay, so I'm gonna do the trig sum. I would substitute. Okay, let's do the limit first. The limit that you have is x equal to -2. You substitute with -pi/4, and you have x equal to 2√3. You're gonna substitute with pi/3. So that will be this 2 guy. So it's gonna be -pi/4, and it's gonna be pi/3. Okay, so this is how we have the trig sum. Okay, so that pi/4 to pi/3, and you have 1/square root, and 4 plus x squared, you're gonna substitute 4 sec square. Okay, so this one is going to be 4 sec square, and that the green function, you see the color, and I have dx. Dx is 2 sec square, so it's going to be 2 sec square theta d theta. That is my dx. Okay, so that is my dx. Okay, so it's 2 sec square. Okay, and so you would get, okay, so you would get this one. And now let's forget about the limit a little bit. So it's going to be just copy pi/4, pi/3 like this. And you see that this one can be simplified into 2 sec theta. Okay, and you have 2 sec square theta d theta. Okay, and this allows you to get rid of 2 and 2, and secant square. So you end up with integrate from -pi/4 to pi/3 of sec theta d theta, and integrate secant is log absolute sec theta plus tan theta from -pi/4 to pi/3, and this one will be log absolute sec pi over 3 tan pi over 3 minus log absolute sec pi over 4 plus tan negative pi over 4. Okay, and you're gonna find the number for me. So sec pi over 3 is equal to 2. Tan pi over 3 is going to be root 3. Okay, sec negative pi over 4, it's still root 2. And tan negative pi over 3, it is negative 1. Okay, so the final answer will be in terms of log 2 plus root 3 minus log of root 2 minus 1. Actually, you can answer this one without absolute value because root 2 minus 1 is positive anyway. Okay, so this is how we do the trigonometric substitution, and I already do three examples on this one. Okay, so you see that you're gonna have to memorize this table. Okay, a square minus u square, or you memorize constant square minus function square, you use sine, constant square plus function square, you use tan, function square minus constant square, you use secant. Okay, and this is how we have these three examples. And when you have definite integral, you must, okay, I think the same must, you must plug in the limit. Okay, so you need to find this one and this one in order to do the calculation, and it's gonna make the calculation easier without using any triangle, and normally it's gonna make the calculation easier. Okay, so I kind of like to warn you that you should do something like this. However, sometimes it's kind of difficult to do this one, I know, but use your calculator. Okay, it's gonna be answer, you'll be able to answer it. Okay. Okay, I'm gonna stop here for this part, and I'm gonna do three more in the next part of the trigonometric substitution.